Hello, welcome to today's lecture on the intelligent transportation system in incident management. In the previous lecture, we looked into traffic incident management, and during our discussion, we were able to digress into some technologies that are used in the course of any incident or traffic incident on the road. But here in this lecture, we're going to be looking at some of those technologies. Some we call them intelligent transportation systems that are used in traffic incidents. So we're going to be looking at most of them in this lecture. Also, we're going to be looking at the causes of congestion, majority of the transportation problems we have on the road, and also the categories of intelligent transportation system, looking at it in form of be the communication technology, sensory technology, and the different forms of intelligent transportation system we have under each category. There is no way before we go into the transportation issues or intelligent transportation system without having a good understanding of what intelligent transportation system is all about. Because from basically most of the definitions that we've heard, intelligent transportation system, popularly called ITS, is the integrated and effective use of advanced technologies in such fields as maybe in information, communication, control, sensing, and system interoperation on the basis of complete infrastructure to surface transportation, so as to provide real-time, precise, and efficient transportation service functioning on wide ranges. So, because from this definition, it is clear that it is a combination of leading-edge technologies. So what are the leading edge technologies we're talking about? We have the sensing technology, we have the control technologies, information technologies, communication technology. All these, the combination of all these leading edge technologies used in transportation and traffic management systems. And these are to improve the safety, efficiency, and sustainability of transportation networks, to reduce traffic congestion, and to enhance driving experience. So from this, it shows that the possibilities from ITS, intelligent transportation system, they are endless. And some of the examples of intelligent transportation systems we have, although we're still going to go into some of them very soon, we have the global positioning system, weather information system. It helps us to, it provides us with information about the weather condition, bus information system, traffic and transit management system, real-time information, incident management, emergency management, commercial vehicle operation. So there are lots of examples of ITS applications, that is information transportation, intelligent transformation transportation system. There are a wide range of its applications in this field. So, but before we go into that fully, we are going to be looking at what are the transportation issues. There were some issues in the transportation system that brought about the need for ITS application. And some of it is what we've been able to highlight in this slide. We have emission as a result of the emission of carbon monoxide. We have fuel consumption. Due to high rate of fuel consumption is also a transportation issue. Most especially in my country, there is high consumption of fuel um, compared to countries like China that makes use of electric vehicles or the new latest form of transportation system, and maybe the use of electric bikes and other transportation modes. We have crashes, which is also quite common, and this is also one of the transportation issues. We have crashes in form of accident, congestion. We explain that under traffic incident management, like as a result of anything that hinders the free flow of transportation or free flow of traffic on the road is traffic incident. And one of the traffic incident is also congestion. We have delay, which can be in form of any of the listed issues that I've earlier said. We have effectiveness and also efficiency. So having that effectiveness and efficiency in the flow of traffic is also another transportation issue. So basically, all these issues, all these these are underlying transportation issues that affect the free flow of traffic on the road, which also ensures the safety of road users. Now, for the congestion, they are basic that these are some of the highlighted causes of congestion. We have poor and wrong signaling. When a vehicle is giving the wrong direction, signaling maybe at the wrong time or late on the road, this can also lead to traffic congestion. Traffic natural disasters, maybe in form of earthquake, tsunami, it can lead to traffic congestion on the road, or flood can also lead to traffic congestion. We have accidents. Yes, this is the most common cause of traffic congestion on the road. When there is an accident and there is no proper way of channeling the the traffic, and this will affect the free flow of traffic at that time, and it can lead to congestion. We have lane change. When a vehicle decides to change the lane or cutting in, this also can lead to congestion on the road. Unnecessary braking. When when the vehicle decides to brake unnecessarily, or probably when they are moving below the speed limit required on that particular road, it can lead to congestion. What I'm trying to say here is there are some roads that there is a certain limit of speed, minimum and maximum, where the vehicle is meant to move on that particular road. So if let's for example, if the minimum speed is let's say 25 kilometers per hour and the vehicle is moving let's say around 15 or 10 kilometers per hour, just an example, then it shows that the vehicles coming behind that vehicle will also have to move below its speed because they don't want to run into the car, leading to any form of accident, and that will lead to congestion on the road when vehicles are not moving at the right or the required speed necessary on the road. And we have overcapacity when there are too many vehicles on the road. This can also lead to congestion. So this is just an introduction into the reason, the need for ITS applications in traffic incident or traffic incident management. So here we have the introduction into intelligent transportation system ITS itself, telling us that giving us an understanding that modern societies face many transportation problems and that have a growing adverse effect on their development. So now the introduction of intelligent transportation system will help us to play a crucial role in traffic incident management. And the main goal is to improve safety. Like I explained that earlier, then reduce congestion, we just explained that, and facilitate efficient response to incidents. Facilitating efficient response to incidents, I've also discussed that in the previous lecture under traffic incident management. That is, when these intelligent transportation systems are in place, it helps us to have a prompt response when there is an accident or crash or anything that affects the free flow of traffic on the road. So when these intelligent transportation systems are well adopted on the road network, then there will be to help us to facilitate efficient response to accident or any traffic incidents on the road. And not only does this thing help to improve the response to traffic incidents, but it also helps in free flow of traffic or free flow of movement of vehicles or flow of traffic on the road. We have the categories of ITS technology. So most of the some of these ITS technologies are grouped under these categories. The first one is we have the sensing technologies. There are some ITS applications that their job or their main function is sensing. Maybe sensing like the camera helping us to pick up maybe if there is traffic on the road or if there is an accident. They have been performing the function of the sensing technology. We also have some of the ITS technologies performing the function of control. Some perform the function of information, while some others perform the function of communication. There are some which perform the function of data management and analytics, and also payment and tolling technology. So looking into each and every of these, so we are going to take each and every of this category one after the other, then look at each ITS application or devices that are under each of this category. So we'll be starting with the sensing technology. So for the sensing technology, we know these are technologies that gather real-time data about traffic conditions, environmental factors, and vehicle behaviors. The vehicle behaviors on the road. How is the vehicle responding? We're still going to look into that under the algorithms, like traffic incident algorithms, where some of these devices or these technologies can detect if vehicles are not moving at a certain flow on the road, then picks up the signal, sends it in. But for the sake of this lecture, we are only going to be looking into each and every of these sensing technologies in brief. So, like I said, the sensing technology just helps us to gather real-time data about traffic conditions. It might be in form of pictorial information, it might be numeric information. So, but the major thing here is that these are some of the technologies that helps in sensing. And the first one we have here is called the inductive loop sensor. And this is installed in roadways to detect vehicles' presence and classify types of vehicles. The job of the inductive loop sensor is help us to classify what are the vehicles on the road that are trucks, which of them are motor vehicles, which of them are bicycles. So some of these are brought into the picture, and the technology that does this function under the sensing technology is what we call the inductive loop sensor. So that is the IPS um, device that does that function. We have the traffic cameras. The traffic cameras monitors traffic flow and incidents through video surveillance. So the job of the traffic camera is just to to monitor the traffic flow and incidents and also perform the function of video surveillance. The third one is what we call the radar and lidar sensors. This measures vehicle speed and distance to provide data for traffic management. It helps us to know what are the vehicle speed on the road, the vehicle speed and the distance on the road to help us to provide data for traffic management. Then the fourth application under the sensing technology, we have the environmental sensors. The environmental sensors monitors weather conditions, road surface conditions, and air quality. So this is to help us to maintain, when we're discussing under the transportation issues, we mentioned emission, which is as a result of the carbon monoxide. So in the RTS application and sensing technology, the environmental sensors, this is now the ITS that helps to monitor not just the weather conditions, but also the air quality as a result of emission and also the road surface condition. So these are just some of the sensing technology under the category of ITS. The next set of category of technology is what we call the control It's called the control technology. And under the control technology is where we have the system and tools that manage and optimize traffic flow based on data collected from sensing technology. So whatever data that has been collected in the sensing technology at this point of control technology is when it is being managed and optimized to optimize traffic flow. And under the traffic control devices or control technologies, that is where we have traffic signal control system. And these are just traffic signals in response to real-time traffic conditions, often using adaptive signal control technology. In the traffic signal control system, this helps us to provide a real-time traffic condition. At a particular intersection on the road, you can notice that maybe on a part of the road, on the road, you notice that there are no vehicles going in a through lane, and instead of having the traffic signal showing green for vehicles to move in that road in which there are no vehicles at that intersection at that point, instead of the traffic signal coming up as at that time, based on the real-time information gotten as a result of the traffic signal control system, it can help to delay the green light in order to allow vehicles and other parts of the road that has that needs the movement, the true movement along the intersection to have the right of way as at that particular time. So that is what we call the traffic signal control system, which is a little bit different and also under the idea of the adaptive signal control technology, which is different from having a traffic signal that is already programmed in a certain seconds for the green light, for the yellow and the red light at a traffic intersection. So the next point here is ramp metering. Ramp metering, this controls the flow of vehicles entering highway to improve mainline traffic flow. I remember in one of the previous lectures we were able to look into the ramp metering, talking about the on-ramp and the off-ramp. Like on-ramp, that is vehicles coming to the highway, then off-ramp is vehicles exiting or leaving the highway. Now, the metering that controls the flow of vehicles entering highways to improve mainline traffic flow is what we call ramp metering. This can also be in form of a traffic signal at the point of entry into the highway. There are some times whereby it helps us to manage the number of vehicles going to the highway at a particular time. Because when we don't have the ramp metering at the point of entry into the highway from the ramp into the highway, then that means whatever vehicles coming from the on ramp into the highway can just lead into the highway without taking into consideration the volume of vehicles that are already on the highway at that particular time. So the ramp metering helps to look into the condition of the highway before giving a green light to vehicles on the on ramp to come into the highway at that particular time. So this just helps to manage and control the flow of vehicles coming into the highway at that time. Then the last point under the control is what we call the vehicle control system. The automated vehicle system that enhance driving safety and efficiency, such as adaptive cruise control and lane keeping assistance. No, it helps to manage lane keeping and provides assistance in keeping to a particular lane. So the ITS application used for that is what we call the vehicle control system. Then this will lead us to the next category of ITS technologies, and that is information technologies. Under the information technology, we know that there are technologies that process and disseminate information to users, including drivers, travelers, or transportation agencies. So that means the information technology is not only provided for road users or drivers, but also for travelers and also transportation agencies. So the information is quite on a broad level across different forms of road users and agencies. And the first part of this ITS application or technology under information technology is what we call the dynamic message sign. The dynamic message sign please provide real-time traffic updates, incident information, and travel time estimates to drivers. When we were looking into the traffic incident management, I also made mention of when there is an accident or a traffic incident on the road, then the dynamic message sign, the DMS, will display to road users that are coming into that particular road or that highway that there is an accident on the road. And this gives them a prior information about what the road condition is and the need for them to change the lane in which would have been displayed on the dynamic message sign. So this helps to provide real-time information to drivers about the condition of the road or any form of maybe traffic incident on the road, and if there is going to be a need for them to change the course of their route or also change their lane while using the road or the highway. So the technology responsible for that information is what we call the DMS, dynamic message sign. Then the next one is what we call the traffic management centers. These are central facilities that analyze traffic data and coordinate incident responses. So that means there is a center that is looking into the flow of traffic on the highway, that they analyze the traffic data, and from the analysis of that traffic data, they can help to coordinate incident responses. When there is a traffic incident on the road, the nearest or the first center or the body that gets the information of that accident or that incident on the road or being communicated to is what we call the traffic management center. Either in form of the the camera sensor speaking on the accidents on the road and communicating it to the traffic management center, or via road user putting a call through, and that call is also going to the traffic management center, and through them they are able to provide the necessary analysis and coordinate incident responses by communicating with the nearest or the required emergency agencies, road traffic emergency agencies, maybe in form of the ambulance services or the police or the traffic wardens to manage the traffic or the traffic incident at that particular time. The next point is the traveler's information system. I think it's self-explanatory. This can be in form of applications or websites that provides real-time traffic and travel information to the public. Most of the time here in China, most of the time you get to see people use the traveler information system when they want to travel, and this can be in form of the Google Apps or in form of Didi or in form of the Alipay system that shows the current condition of the road through some of the apps on that particular app on Alipay or any of the apps. So this helps to provide a real-time information about the road condition, about the travel information to the general public. And when there are some cases when there is an incident, then this can be seen through these applications or websites. The next form of the next category is the communication technologies. So the communication technology or communication system that facilitates data exchange between vehicles, infrastructure, and users. So these are under communication technologies. So the one that facilitates exchange of data between vehicles, infrastructures, and users. So the first one we have under this is V2R communication, which is also called the vehicle to infrastructure communication. This only enables vehicles to communicate with traffic signals and other road infrastructures, compared to V2V communication, that is vehicle to vehicle communication. This allows vehicles to share information about their surroundings to ensure safety. That is V2V, and this also helps other vehicles to have an idea of the information at, at that particular time from those vehicles that are already on the road at that time. So the third one is the dedicated short range communication, DSRC. It's a wireless communication technology specifically designed for vehicle communication. So the last one under the communication technology is the cellular vehicle to vehicle, which is called the CV2X. And this utilizes cellular networks to support V2X communications, enhancing connectivity for vehicles and infrastructure. So it's just a circular network that supports the V2X communications in a transportation network. So that concludes the last part for the communication technology. Then we move to the next category, which is the data management and analytics technologies. And under this, we have the big data analytics, we have machine learning frameworks, and we have the geographic information system. popularly called GIS. Management, data management analytics technology. This system analyzes and manages the vast amount of data generated by ITS components. So the management of the data that are generated with the other ITS components like the camera sensors, the loop, and the rest of them. How these are being analyzed and being managed is under what we call the data management and analytics technology. And under it, we have the big data analytics, that is, the techniques for processing and analyzing large data sets to derive insight about traffic patterns and behavior. So that technique, those techniques, those procedures that are used in processing and analyzing the, the large data to have an understanding of the traffic behavior on a particular road network is what we call the big data analytics. Then the machine learning framework this use this is used for predictive analytics in traffic forecasting and incident detection. So they are majorly used for forecasting and incident detection, and they are also predictive in nature. While the last one is the geographic information system, and these are tools for visualizing and analyzing partial data, often used in traffic planning and management. So it comes with the visualization of the data and analyzing that data in traffic planning and management. The last part under the categories of ITS is the payment and tolling technologies. Under this, we say we have the electronic toll collection ETS, mobile payment solution, dynamic pricing system. Payment and tolling technologies. This system enables electronic toll collection and facilitates seamless transaction for road users. I can remember in Nigeria, my country, before the introduction of electronic toll collection, at the toll point or what we call the toll gate, there is always traffic congestion as a result of vehicles waiting on other vehicles to be attended to at the point of toll, so for their tolls to be collected, then proceed for other vehicles to also come in. So during this period, before the introduction of electronic toll collection, you can see that this is done manually. That is, there is a personnel who is at the toll collection points, collecting cash from drivers. Then sometimes you have to give them the change from the amount of money they are being given. And all this is kind of a little bit time consuming and it causes a lot of traffic congestion at the toll points in the country, most especially in places in states like Lagos at the toll mainland toll collection point. So before the introduction of the electronic toll collection that makes it seamless, it makes it easier, and this helps to reduce the traffic congestion at the toll point or what we call the toll gate. The next one is the mobile payment solution. The mobile payment solution, these are applications that allows users to pay tolls or fees through their smartphones. And this is also made easy compared to going to the banks to pay in cash or make payments for any form of toll or fees or charges at the bank or having to go to the required personnel's office for payment. But with the introduction of the mobile payment solution, it makes it very easy for all these road fees and charges to be made up to be paid effortlessly. Then we have the dynamic pricing system. These adjust toll rates based on real-time traffic conditions to manage congestion. So that means when they see something is dynamic, that means it is going to change. It changes. It is not static. So they are not fixed, but they change based on the real-time traffic conditions. And this also helps to manage traffic congestion. There is a whole topic for this because pricing or toll rates are being adjusted at some certain part of the highway or on the road in order to discourage users from from using that particular highway or from using that particular road in order to be able to use other alternative roads. So when the dynamic pricing system increases, this is just to show that road users are encouraged to use other roads as at that particular time. So the pricing system of toll is being raised in order to discourage them from using that particular road at that time. and to use other roads, maybe due to one condition or the other at that time. So we can see based on these categories of ITS technologies that they work together to create a more efficient, safe, and user-friendly transportation system. And each of them, they play a vital role in modern traffic management, facilitating better decision making and enhancing the overall travel experience. And there are various importance of the intelligent transportation system. The first one is to improve safety. We cannot overemphasize the importance of safety in the introduction of any technology or introduction of any ITS application. And this also, the introduction of safety helps, improvement of safety helps to reduce the accident on the road by providing real-time information about the traffic conditions, the incidents, and the hazards. So the ITS can help drivers make informed decisions, potentially reducing accidents and injuries. Just like we said with the dynamic message signs, there is information about the road condition is already displayed on the DMS. So vehicles or drivers flying that road or coming on that road can see that there is an incident ahead. So it helps them to be careful or maybe to reduce their speed or to change their lane to the required lane that has been displayed on the DMS. So we can see that ITS has played a major role to potentially reducing accidents and injuries compared to without the introduction of that technology, it might have resulted into secondary accidents on the road. Also, it helps in the ITS technology. It helps to facilitate faster response time for emergency services through the real-time monitoring and the communication leading to better incident management. The second point is it helps to enhance traffic management. And enhancing traffic management can be in form of traffic flow optimization or the real-time data utilization. The ITS helps to optimize the flow of vehicles through smart traffic sign control, incident detection system, and adaptive traffic management. And this helps to reduce congestion. The next point is the environmental benefit. What role does ITS play when it comes to benefiting the environment? We already said it as one of the transportation issues earlier in the lecture as emission, the emission of carbon monoxide. And one of the role of ITS or the importance of ITS is to help to reduce emission. Efficient traffic flow and reduce congestion lead to lower vehicle emission. So when there is efficient traffic flow, when there is less interference of the movement or the normal flow of traffic, then there will be a reduction in the emission of carbon monoxide compared to when there is traffic congestion or traffic jam, and that will enable more emission of carbon monoxide being released as at that particular time. So, and this also helps to contribute to improve air quality and reduce environmental impact. The ITS also supports the integration of public transport, carpooling, and non-motorized transportation, which also helps to promote sustainable travel options and reducing the number of vehicles on the road. So when there is the introduction of carpooling system or the public transportation, rather than about 20 or 30 people, road users or passengers using the public transport, rather than they using their own private cars or taking um, a taxi, which will have increased the number of vehicles on the road. Having the introduction of the public transportation or carpooling will help to reduce the number of vehicles and also the emission of carbon monoxide. The next point is urban mobility and accessibility. This also helps to enhance public transportation system by improving route planning, schedules, and real-time passengers information, making public transportation more reliable and attractive. So the mobility and the accessibility to public transport makes it much more attractive and reliable for road users or for people to make use of. And it also helps to improve accessibility for pedestrians, cyclists, and individuals with disabilities by providing better information and safer infrastructure for them. Then the last point we have is informed decision making for travelers. We've already explained that also when we're discussing some of the ITS applications or the technologies, as they provide real-time updates on traffic conditions, that is the travel time, the incident, empower travelers to make informed choices. It helps them to make informed choices about their route and departure time, leading to more efficient journey. When you're going to the train station, through your application, through applications or website, you can see the possible time that the train will be leaving the, the station. And this can help road users to make effective decisions on when to leave their houses in order to get to the train station to be able to meet up with the train. Rather than when that information is not there, the road users or people will have to be at the train station earlier, waiting until when the train arrives, then boarding the plane. But with the ITS in place, it helps them to be able to track the time that the train will be at the station and helps them to plan effectively where to transport or to move to that station at that particular time. So this not only helps with the traveler information system, but it also helps with mobile applications. That is, mobile applications that provide personalized and traffic information and alternative route suggestions which enhance users' convenience. That is, even if a road user, an individual going to a particular city or going to another state, if they don't want to make use of the train, it will also provide alternative route for them to be able to get to their destination without necessarily and giving them wide range of options to pick from through mobile application. So that is it on intelligent transportation system, and I'll see you in the next lecture. Thank you.